Hello class. Today we're going to learn about the law of sines. Now before I talk further about that, we're just going to jump back into and remind ourselves what we have been talking about, which is the area of any single triangle being a triangle of ABC or ABC in this area where this is acute. And actually let me write that in, an acute triangle. Ah, so cute. And in this one here on the right, we're going to call this our obtuse triangle. And with that being said, if we find the area, reminder, area here is represented as k, it can be any one of these expressions depending on your reference angle. So if it's C, it's going to be referring to sides A and B, which are the ones adjacent to it. Now, if we look at all of these expressions, we actually can do one thing to each one of these expressions, which is divide by some same factored amount. Which, let's say I'm going to divide by this amount of 1/2 ABC. Now, actually, I'm going to want to color code these. And let's just do, this might take a while, but I'll try. A, B, and C. If I take this, and I'm going to copy that. If I take this, actually, let's get the whole thing. Copy and bring it over. If I actually take these expressions and divide each one by these terms, look what happens here. The halves are going to cancel out. I'm going to use a different color this time. I use red. I like that one. All right. Boom. These will cancel out. Your C's will cancel out. Your B's will cancel out. And you're left with sine of A over A. And I'll rewrite that. But let's keep going. 1/2 will cancel out. A's will cancel out. C's will cancel out. And you're left with sine of B over B. And so on and so forth. And now you get these new expressions, and this might take me a second to write them all out. Let's do sine over, and I'm going to say this is equal to, and I'm going to select. Sorry, just give me a second. Bring that over. Bring that over. Erase this here. And now we're going to do A over A, B over B, and C over C. So let's note that this is sine of angle A over side A is equal to sine of angle B over side B, and also equal to sine of C over side C. So all of these here, like what this expression is saying, is that if you have the sine of angle, whatever angle it is, and you have it over, that if this is a known here as well, that's equal to the proportion of this sine of that angle and its corresponding side here. So this relationship can be used to find other sides of the triangle or other angles within a triangle. So these expressions are actually what we consider our law of sines. Law of sines. So let's try to put this in application. So for this given example, we have a triangle ABC, and we need to find side AC, which is here, side B, and side BC, which is side A, for the given triangle A, B, and C. So we're going to try and use actually law of sines to do this. So to start off, to use law of sines, if we're trying to find, let's say, AC, which is side B, we can start off by writing the following, which is we need sine of B, and this will be AC. So let's say AC is listed here is equal to this, and let's move that over. Okay. And that's over side B. And now let's use a given here, and one of the givens is this 25 meters. So we're going to say that this is now side or sine of C over side C. Now you already note that here we have possibly two unknowns. We have this unknown B, which you're looking for, and we also have this, actually this unknown here, angle C. But this angle C can be solved by simply saying 180 degrees is the total amount of a triangle, so angle C is equal to 180 degrees, that's the total amount, minus the summation of the other two angles, 110 plus 20, which is going to be 130, so 130 subtracted from 180 is going to be 150. Oh, sorry, just 50 degrees. So that is angle C. So let's start plugging in information and say sine of B is 20 degrees over, we're still looking for B, equal to sine of 50 degrees over 25. And we're not going to include units right now because everything is going to be in the same units right now. So we're not going to include that, but I will have that in my final answer. So I'm going to reorganize this and isolate B by doing cross multiplication, then dividing over sine of 50. So we're going to have 25 multiplied by sine of 20 degrees over sine of 50 degrees. And in this case, what we're going to get is 25 sine of 20 divided by sine of 50. Make sure you're in degree mode, and you're going to get approximately 11.2 meters. So let's write that in, 11.2 meters. Now as we begin to solve for BC, which is side A in this case, I'm going to want you to take a moment and try to do it on your own. So please pause the video and work on doing that yourself and seeing what you get. Alright, so let's continue. So we're looking for side BC in this case, and we're looking for the A side, so I'm going to put sine of A over A, and this is going to be equal to, again, we're going to use what's given to us initially, which is sine of C over C. Let's plug this in. Sine of A is going to be 110. This is our your obtuse angle. We're looking for A is equal to sine of 50 again over, and this is your 25. We reorganize like we did before. A is now equal to 20. We have cross multiplication, so 25 times sine of 110 degrees over sine of 50 degrees, and that's all equal to, approximated. And we're going to get 25 times sine 110 divided by sine of 50. 30.7 meters, and that's going to be this one here. I should have done it in blue, but oh well. 30.7 meters. And there you have it. So we found side AC and BC. Alright, let's do another example. So this video is running a bit long, so what I'm going to do is actually end this part here. You can catch up on the next example next video, which is talking more about the ambiguous case. Also included in Law of Sines, make sure you watch part 2. See you all next time.